What is a polygon? What do we mean by a polygon? In this video, I am going to give you a precise definition for a polygon. This is our definition. Let P1, P2 up to Pn be endpoints in the plane. So, let's consider this board as our plane, and it says n should be greater than or equal to 3. So, for an example, let's use these points P1, P2, P3, P4 and P5. And the cycle of line segments P1, P2, P2, P3 up to Pn, P1. That means P1, P2, P2, P3, P3, P4, P4, P5, finally Pn, P1. This one. Here n is 5. Obey the following two conditions. Now our first condition, no two adjacent line segments are collinear. So what are the adjacent line segments? So this one is adjacent to this, and this one is adjacent to this. This one is adjacent to this. This one is adjacent to this. Again, this one is adjacent to this one. So, no two adjacent line segments are collinear. If you consider any two adjacent line segments, they must not be collinear. The collinear means if you consider two line segments like this, and if we draw a straight line through any one of line segments, the other line segment, if the other line segment is not on this straight line, then we say that these two line segments are not collinear. But what happens if we consider these two line segments? If we draw a straight line through one particular line segment, the other line segment lies on that straight line. In other words, both of these line segments are on the same straight line. Therefore, we say that these two line segments are collinear. Now, if you look at this this cycle of line segments, if you consider any two, they are not collinear. Okay, so the first condition is satisfied. Now let's look at the second condition. No two non-adjacent line segments intersect. Non-adjacent ones means if you consider this particular line segment, this one is adjacent and also this one is adjacent to this particular line segment. So this one and this one are not adjacent and they must not intersect this one. And likewise, if we consider any two non-adjacent line segments, they must not intersect. That means if you consider this one, this is adjacent and this is adjacent. These two are not adjacent and they must not intersect. Likewise, so if you consider any pair of non-adjacent line segments, they must not intersect. And also, if you look at the first condition, it also says if you consider any pair of adjacent line segments, they must not be collinear. Now, here, as we could see, second condition is also true. Therefore, this is a polygon. Now, if this is a polygon, the closed region bounded by the line segments. Closed region bounded by the line segments. Now, this cycle of line segments bounds a region. That region, including the line segments, we say that the closed region. In other words, that region includes the line segments as well. So, that particular region, the closed region, we call it a polygon, and also the points are called the vertices of the polygon, and the line segments we call them as the edges of the polygon. Now, our question is, can any cycle of line segments bound a polygon? Let's see. So now, if you consider, let's consider this one, P1, P2, P3, P4. Now we have 4 points, P1, P2, then line segments are P1, P2, P2, P3, P3, P4 and P4, P1. Now if you look at this cycle of line segments, now let's look at the first condition. No two adjacent line segments are collinear. That means if we consider any pair of adjacent line segments, they must not be collinear. But if you consider this pair, P1, P2 and P2, P3, they are adjacent, and also these two line segments are collinear. Therefore, the first condition is false. Then definitely this cycle of line segments does not bound a polygon. Okay, so if you look at the second condition, just look at the second condition as well. No two non-adjacent line segments intersect. That means if you consider any pair of non-adjacent line segments, they must not intersect. But if you consider P1, P2 and P3, P4, these two line segments are not adjacent, but they do intersect at this particular point. Therefore, second condition is also false. If at least one of these conditions are false, definitely that cycle is not a polygon. Okay, but okay. So now let's see another example. This one, P1, P2, P3, P4, P5. first condition, no two adjacent line segments are collinear. That means if we consider any pair of any pair of adjacent line segments, they must not be collinear. So if you consider this one and this one, adjacent pairs, they are not collinear. This one and this one, they are not collinear. This one and this one, they are not collinear. This one and this one, they are not collinear. This one and this one, they are not collinear. Therefore, first condition is true, but let's look at the second condition. No two non-adjacent line segments intersect. That means if we consider any pair of line segments, any pair of non-adjacent line segments, they must not intersect. But if we consider P1, P2 and P3, P4, they are not adjacent, but no, P1, P5, let's say P1, P5. P1, P5 and P3, P4 and yes, P1, P5. So here let's say let's use the let's use this like this. P2, P2, P3, P2, P3 and P5, P1, P2, P3 and P5, P1, they do intersect at this point. Therefore, these are not adjacent, but they do intersect. Therefore, the second condition is false. In that way, you can identify easily and clearly define what is a polygon. And now I hope you have this question. If you consider this one, P1, P2, P3, P4. Now, if you consider P1, P3, P4 points and their corresponding line segments, okay, P1, P3, P3, P4, P4, P1. Those three line segments obey these two conditions, and therefore this region is a polygon. Okay, but if you consider these line segments P1, P2, P1, P2, P2, P3, P3, P4, P4, P1. So, if you consider, then if you look at the first condition, P1, P2 and P2, P3 are two adjacent line segments, and they actually they are collinear. Therefore, first condition is false. Second condition, that is true. Anyway, now if you look at the definition, these these line segments cannot bound a polygon. Okay, anyway, this region is a polygon, but in the definition, we use it like this just because we do not want this kind of intermediate points to be considered as vertices. Therefore, in our definition, we have this one. So one purpose of having the first condition is to exclude this kind of situations. So I hope you understand that issue as well. So that's all, and thank you for watching.